screen before I go share screen.
I just wanted to add one thing. So existing Kaggle groups, they go over competitions that ended recently, or a year or so, or maybe sometimes more, because they want to like fully collaborate and don't violate any Kaggle rules. And right now, two groups are doing NLP competitions, just because they were kind of interested in doing that.
Okay. Yeah. Who was that speaking?
That's Yuri.
Oh, hi Yuri. First time you talk. First time I actually hear your voice. Sorry about that. All right. So welcome everyone. This is October 27th, meeting 8, NLP deep dive in RNNs. Although, from all the presentations, that won't necessarily tie us to that, but whatever you can present that we have. And again, if you could turn on your video so we could see your face. If not, if you have a problem with video, that's okay. Again, your name, so we know who to reference, all the people, and share your knowledge. I attended the TWIML Fest and they gave this coded bias, which was basically on Joy's, I think he mentions it, or at least Rachel mentions it in the book about having a lighter skin face, being able to do the facial recognition of like IBM or Amazon or something. So it was kind of like her journey type thing. I like Rachel's presentation versus this movie because this was kind of sort of like only on her and kind of not like a broader spectrum of how Rachel presented it in when we had the lecture in lesson 5. So, but if you wanted to watch it, I think there's a link or something. Right now it's like in only personal private preview or something, but I think it's on the TWIML thing. I think they're going to have another showing or something like that. So more than welcome. It's a good entertainment. Here, honey, here's what you didn't know type of thing. And now we go to you, Ling. So let me go to the screen here.
I am on the docket.
Going to make co-host.
Okay.
And now you can share your screen.
Okay. Sharing options, one participant, multiple. Share. So share screen. What? Sorry. Zoom request. So do I have to request remote control? What steps do I follow?
You should be able just to share screen.
Yeah, I think so too.
And then pick the screen you want to. Oh, maybe I should stop sharing my screen.
Yep. I got it now. Yep, it's here. So I will share that and let me know when you can see this.
Yes.
Okay. So guys, not as prepared as I wanted to be. And because my original thought was I'll take a data set as I've seen everybody else do from a different source and just go through it with your own view. I did not do that. And I just went through the book. I took the chapter, I copied it over. You can see that here. And then, so I'll just go through it. And I'll reach a point right next to text generation, after which, at which point it's still running. So I was kind of late, quite late. But I'll explain the concepts. And my way of looking at this was a lot of 3 things that kept coming to my mind, and I'll use that perspective. Jeremy, I really want to call him a professor. He doesn't have the designation, but I think we should. But so he uses the perspective of looking at the code and just NLP. It was very difficult for me. This is my first time exposure to NLP per se, or rather dive into the models and the code. I've done bits and pieces in a scattered way, but not even in a scattered way for NLP. So without much ado, I
Hey,
think
Yulin, can you increase the font size a little bit?
absolutely.
Thanks. Thank you.
Okay, and I'm going to hide the left bar. So this is the installation. So the three perspectives I have are one, language processing. So which is basically, if you look at how compilers are built for any language or how any language is written, um, they do exactly this. They don't necessarily go into numericalization, but that is better and better processing for the grammar. And so that's one thing I'll start with. And essentially, what they're doing is they're taking words, and I'll talk about it for a minute. They're taking he's taking words or a corpus of words, which is text, and he's batching, grouping, streaming, calling a sequence these, but essentially creating matrices out of it, right? So if I step back and think, how can you take a book and create a numerical matrix out of it so that the algorithms can be applied? So, and that is all what we've typically called pre-processing in other chapters or notebooks, right? That's what pre-processing consists of. And it's three steps: numericalization, tokenization, and then subword tokenization, to capture nuances of different languages. So that's one big thing. Then within the model, I played with RNNs in the context of the deep racer for AWS, but only in a very light way. But I thought the concept of having an agent and somebody external coming in and learning trickle by trickle was very interesting. I didn't quite understand how he's referring this to RNN, so I'll not go into that. But I like this concept in a super big way, where what he's doing is typically what we say is y is equal to fx, and right, and that x can be a linear expression, which is weighted sum of everything input, and then you apply a softmax ReLU or sigmoid function to it, and that's the output of a node. And you have multiple nodes, and lo and behold, you have an entire network. And now you are suddenly fine-tuning the network using batch sizes or fine-tuning parameters and so on. But what he's doing is, it's the way the data is structured, and it's neither supervised learning, it's not unsupervised learning, it's self-supervised learning. And that's amazing. And what he's doing is, he says, you read a sentence, and once, however you've cut it using those batches or smaller streams or whatever, you say X is equal to that sentence. And by the way, Y is equal to that sentence plus the next one word in that sentence. Now forget the word sentence, because everything here is a token, and you have a sequence of words, right? And so what is a text? It's nothing but series of numbers. And if you can predict the next number from a series of numbers, and instead of one row of data, you have millions of rows of data, right? That's what we end up doing, right? We have rows and columns, and one of the columns is the predictor or the classifier or the predicted variable. Everybody else is a predictor. So just that fact that Y consists of X plus 1, and you have so many rows, and you process them and you size them so that it fits in the memory. That's essentially what he's doing, right? And so that part was really amazing. And then the applications are great, because when you predict the next word, you are literally, and so that's predicting what I think Gmail is now doing very efficiently. I think over the last 4 weeks or so, or a little more than that, they've introduced a lot of things. And then the other is classification of sentiments, right? Which kind of like which is very similar. So the concept, self-supervised learning, and there's a universal language model fine-tuning fit approach. I mean, this was great. He takes the wiki text as a model, applies the unfreezing, freezing, and all of that, and then fine-tunes this, right? So a lot of the general approach we've seen with neural networks, but very NLP specific after a point. So pre-processing the text, numericalization, tokenization and the creation of the model. And then this is all the splitting and the spacey tokenizer. And to me, instead of, he has such great detail in the rules, as long as I understand the rules in the grammar, right, which is what this is, then somebody's done a lot of hard work and we can use it for as a given, right? It's the luxury of standing on the shoulders of greats, right? I mean, that's what it is. So this is actually all this, everything that is there in a language has been broken down with a token, and the token kind of representation is with XX and something, whatever that may mean, right? So that's and then he talks about subword tokenization, which is for languages. The Chinese character example was really great, that they don't have spaces, and what do you do about that? So essentially, you know, if you start to think of English as just a series of tokens without any spaces to separate the tokens, what you're essentially doing is you are breaking the words down. So when he actually does this, I was thinking, is he trying to use pronunciation like the way we learn how to pronounce things? They seem to be breaking like that, and I was starting to think like that. But yes and no. He's essentially saying is each character can be a token at extreme one end, and there can be another formation of tokens, right? Which is what he ends up describing as subword tokenization, right? So that's how he comes to this point. Then once that tokenization is up to a certain level, I don't know how to describe what's perfect tokenization, but after that he does the numerical transmit or like categorization, or like not exactly categorify like we saw, but turning it all of this into numbers like matrix. He's coming closer and closer to that, right? And so that is what he's doing here. Then there's some series of things he shows, and I'll talk to that in a second, where he talks about, so I wrote a note, give me a second. I can find it, but what the way I interpreted all of these as having a batch size of 6 and a sequence length of 15, or of 5, and so on and so forth, is again finding the most appropriate size in a matrix given the limited computing environment, right? And to me, a matrix has rows and columns, and that's what he's doing here. I mean, he says there's a batch, and you can have 6 rows, and you can have, let's say, 5 columns, which you call sequence lengths. And then he steps back, and which is again where the language, form came in, is if you look at different languages, they talk about streams. Like, for example, C says print F, right? So if you look at it, there's streaming. C++ copies the same, Java takes the same. So that serialization thing sort of starts to come. But of course, because this NLP, he's not really using that. He's simply saying, look, as long as we understand that if there are different text books, right, or different kinds of documents, you don't break the document or randomize within that set, right? You take the document, take a series of documents, and randomize the order, but within each document, you have streams and mini streams. What are they doing? Okay? Again, a stream is a series of batches, and he's trying to fit these sizes. Now, somehow in my mind, I was trying to relate this to how he described tensors and matrices and the difference, and how I think some Cliff Halfer is joining. I pressed admit, he should be able to join. So essentially what you're doing is you're taking gobs of data coming in, you have structured them as streams. You can randomize between streams across epochs. We've learned the concept of epochs, right? We know the value of picking small data sets for stochastic gradient descent. I don't know how, if that's SDD is the right thing to say in this context, but that's what it is, right? So then once you have that gob, you take that, you put it in streams, mini streams, batches, and lo and behold, you have a numericalized structure, and you can represent it in a tensor, which is of equal length. Now, again, the moment you start talking about things of equal length and sizes, you have the problem of padding that comes in, right? And in images, we saw how that is addressed. And then he goes on to describe some techniques here from a language perspective. The nice thing he's done, which I think is a great abstraction, is this data loader, right? So I know that what scikit-learn does is there's a sequence of things you have to do, whether you're doing web scraping or taking the known data sets and everything, and you see the steps. So you can write methods and capture that, right? Or to read data, different data sets. But what he's done is with data loader, with the kind of parameters, and if you do question mark, as he describes himself, you can go down and see. He's brought it to a point in Fast.ai that you can read everything, right, in single statements, right? If you know the parameter values, which again is simplified, so which with defaults already set in lower levels, right? So then therefore he uses the data block concept and the loader concept, and he creates the boom model, right? So then he says, you show a batch, and this is how a batch looks like. And then so fast forward to the fine tuning, the language model. I mean, he talks about RNN and AW-LSTM. I'd once seen scientists present something on LSTM. I'm beginning to understand, but today I'm not going to venture to speak about it. I'm not there, absolutely not there. Right? So then interestingly, this was very interesting concept to me. This was the third dimension I was looking at it. Throughout NLP, he has used the concept, and actually whenever you take a neural network and for a node, and he used it for random forests, so we talked about entropy and cross entropy, and we know from information theory, the number of bits that are required to represent data. And we know that from sampling also, from voice sampling, and how so much voice is now compressed over mobile networks and so on, right? And they're all using the same theory, noise to signal to noise ratio underneath it, right? But in this context, the way he's used, NLP has absorbed the concept of perplexity is that can you find distribution, right? A probability density function, which can capture the underlying text, so very high level speaking, right? But very specific and just jumping over the concepts, right? What he's saying is that, and there's if you like Google, this came up was, in English language, you need 7.5 bits per word or something like that, right? Or 257. I mean, there are numbers like that. So essentially, you don't have to overcomplicate. There is a fixed length size, and I think he refers to that paper somewhere. You can do that, and that's exactly what that is where this starts to happen, right? And once we have done so now suddenly, besides the accuracy of the model, and we understand accuracy quite well, this is classification accuracy things he's not talking about. You also have a perplexity measure, so which is now starts to creep into the performance measures of the model, right? Which is where he came to this point. Saving and loading models. This is very essential. You see, this is still running. I'm late today. Sorry. And then he talks about text generation. I can pause at this point. If somebody has other people who are planning to speak for today have things beyond this, because you're seeing that I'm jumping over concepts. I don't have an executed thing.
I have a question.
Yes.
On the LM data loader, are there other data loaders for this type of thing, or we just use that?
So I was looking up data sets for today's demo, which I didn't actually apply. There are about a dozen or so open source data sets that we should be able to use and apply. There are, and these are well curated, just like this one. There are 2 from Yelp ratings, 2 from Amazon. They're all coming from known institutions like Stanford, MIT, and Google and all. So I believe we can apply that. I didn't try it though, Andy, today.
Yeah, that's the data sets, but I mean the data loader itself, right? When he's used the LM data loader.
Yeah. Yeah.
Is that the only one we can use in Fast.ai, or is there others we can?
So I'll give you my version of the answer. I don't know his precise answer. First thing this time I read listened to his lecture, and so don't quite remember his words. So the way I look at it is like this. Fast.ai is sitting as a library over multiple layers of like different libraries in Python, right? So if I can extract data from any other thing into my notebook, I really don't care if I'm using Fast.ai specific function or not. But I do care because I'm doing Fast.ai, so I should know how to use his functions, right? And I'm not there, kind of using his syntax and all and everything. So
Yeah, I guess this goes back to the point that Dave was bringing up in that, I can do Shift Enter and I can copy that LM data loader and use his same syntax, but at what point do I need to stand on my own, so to speak, versus using his code all the time? I understand use that data loader, but of course you can just look into the data loader and then feed in the parameters yourself. You don't have to use his data loader. You can kind of make your own, so to speak, just so you understand. Just like what Daniel was doing when he created his own classes, he just kind of picked out the classes out of the notebook, but he put it all in like a sequential step. And I thought that was key for learning. And I think that's a good way for me to learn, in that I'm not just like shift entering. And then you see how many parsing things he has. Like if you go up in your notebook,
yeah.
If you go up, just go up a little bit, up, 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 just up, up, up. Yeah, so that's, but you see where he's doing all these joins that go up a little bit. So he's showing you how these joins are done. And I'm like, okay, I'm not understanding what I'm doing here, right? So I'm just like joining. So.
Well, that's, what that is actually is him showing us just through the basics of Python, the complexity of his data sets. So his data sets are fairly complex structures, and then using like the space, the quote, single quote space, single quote dot join, all that's doing is joining together separate words with a space in between to make them look like sentences.
Right.
Yeah, and you can do any delimiter there. So
Right.
inside that, the single quotes could be an underscore. It could be, I mean, it doesn't make sense in this context, but it could be a comma. It could be a tab. It could be anything. It could be an I. Just because.
So it's the opposite of taking the original words and breaking them up by spaces. He puts the spaces back in. And all that is just good old Python dexterity, which is that mastery that I'm hoping to achieve just working through this. So but that's a good observation.
So I'm not there, is what I'm saying.
Oh yeah.
I would get the data set and I wouldn't normally do this. I would just, do the shape thing, and then I just do straight data loader. So that was my kind of question.
Well, actually, you kind of mentioned two different things. The data loader themselves are even more specific instances of his custom classes, which are very important, that I guess we know about. And then just this basic use of Python to show things is also another skill set, also very important. So I'm glad you brought that up.
So I totally agree with the conversation on these parts. So so here's the mental block I go through. Like I think it's a block, right? So which language do you think in, right? And to the point that Dave is bringing in, and he was alluding to his thinking, and I remember that question he had is when So I created a bunch of functions a while ago in using scikit-learn, right? I have them somewhere and I can use them, but now I use Fast.ai. And do I go back and rewrite? Do I refactor that code, right? Or do I continue to go at this pace? And then my translation is in Office, like when something comes up, as long as I'm able to let every individual use it in a way they like, and every person and the job is getting done, and things are well documented and can be carried over and carried on and so on, and I'm able to read the code, right, in whichever way it's written. So in this case, yep, it will take time to understand this versus another person like expert who would have written it using data block, right? I think it's okay. And if you and one more thought, like, I'm not pushing the point or belaboring it by any means. This is something very mind-boggling what Jeremy said in the beginning of the class. He says, my goal, this is my whatever X3, 4th, 5 year, 5th year, whatever. In a couple of years, I want to eliminate this, right? I want to improve it so that it's not needed, right? So in year 10, he's looking for not needing anything he did in year 1 or year 5, year 6. What would that look like? How will we learn? Like, I don't know. Was it bad? Good?
That's the power of abstraction.
Yes, you're right. You're right.
But at least we're giving the opportunity here. This is abstracted pretty high, but then he wants us to see one level before. So we kind of stop and tease it apart. We're not having to go back too far. We're not going back too far deep into the Python, but maybe from his world back into the PyTorch world.
Yep.
And maybe a little bit into the Python world, but that's about it. I'm afraid to think of where things will go beyond that. It's just like if you're into Kubernetes or Docker, how much further can we abstract computing systems?
You're right.
It's amazing.
You're right. And Kubernetes, came out of Google, is the fancy thing, but guess what? It's just VMs that WebLogic and WebSphere were using. They're just microservices based, right? So.
So anyway, it's good stuff.
Yep. No, to agree. Over to you, Andy.
Going back to Andy's question, I guess, NLP is, again, a topic I'm not that familiar with. I'm probably more familiar with computer vision. But the nice thing is he covers this, I think, primarily to introduce one other, it's like this idea of a new kind of neural network, aside from the ones that you've studied so far, which is the one that kind of a neuron that holds memory, that during, actually all of them hold memory. They memorize to some extent the patterns, right? But in this particular case, they introduced a new kind of memory that is held while you're running through the sequence. It's like, for me, the point I think he's trying to get at is the RNNs, or recurrent neural networks, are another type of neural network that kind of is distinct from all the other ones. And although we haven't covered CNNs yet, which is another type of neural network, he's basically surveying all the kinds of neural networks. CNNs are more like the normal, fully connected neurons that we've covered so far, but RNNs are somewhat distinct, and they're not always, and they kind of, like anything else, AI or deep learning goes through its fashion. Like, there was a time when RNNs were like really more prominent for NLP. Today, people are moving towards the ones that I think Daniel is going to cover, which is the
LSTM
transformer type stuff. But I think it's very instructive for us to learn this. Not so much as, I don't know, I haven't applied it that much, but This idea of a neural network, a neuron that holds a hidden state while you're processing and then basically discards it afterwards. If you think about it, when the difference between this type of neural network is that if you go through the language model example in the notebook, it's like there's this H, right? And I've seen articles. There's a nice article by this guy named Terence Parr, and he's trying to understand what RNNs in. I haven't completed that article yet. I'll try to post it. But his idea is what exactly is H? That if you go to the notebooks, there's this hidden state that it processes, and it's not exactly it's not exactly an activation because, well, it is kind of an activation, but it's not the final output kind of activation because it's like it gets updated as you go through from one layer to the next layer to the from the next sequence token to the next sequence token until you pass through the whole data set. Yeah, so it's kind of different. So that's one is this idea of a new kind of neural network. The other is, I think, going back to your question, Andy, about what types of text data loaders they are. In Fast.ai, I think there's two types of data loaders. One is the language model one, and the other is the text data loader. So the language data model is kind of interesting because it's like, you know how we use transfer learning for a lot of our tasks. The language model is a pre-trainer. It's the one that learns, but it's not our final task. So, so basically, what he created was two data loaders, one for the language model and the other one for like things like text classification. So I hope that answers your question.
Isn't the unique thing here the sequences?
Yeah, but the way that it processes the sequence is it holds a hidden state. It's like it starts out with I think 0, and then when it reads the first token, it gets updated, and then when it needs it then reads the next token, it gets updated again. But it's like it's added together, right? So you there's this. It again uses that same concept that we learned, this concept of embedding, where each token, each word, or each is looked up in a dictionary, something like a dictionary. It has like a long, basically a set of numbers. Basically, it's an array of numbers, and that gets fed into the neural network, and that comes out with basically an activation that then is like fed back in. It's like it's added. It keeps getting added. So there's this state in the as you're reading through the what do you call this the sequence of tokens. There's this hidden state that's not necessarily the output. And at the end, it goes through after that, after going through the sequence, you then go through this something like a normal, logistic regressor, or basically it goes through this network and says, okay, based on the value of this, it comes out as either a positive sentiment or a negative sentiment or something like that. So that for me is the different kind of neural network. It's the first is this idea of it's another type of network, and it's not always like in favor because today it's still being used. By the way, this idea of RNNs, LSTMs, even though for text, I think machine translation for like translating between languages. Transformers are more powerful now, but for other fields, I think especially for things like genome sequence analysis and other time series kind of data, NLPs are still very much in use. So yeah, definitely it's like this idea of neural networks, a neuron that's like holding state while you're doing the training, while you're doing the inference, actually.
Right. And again, isn't that kind of because of the supposition of the sequences where you have the independent variable and the dependent variable, where the independent variable actually has the n+1 as the known predicted word?
Yeah, that's for the language modeling.
Yeah.
So
that's an amazing concept, just I think in general, because that's not how the imaging works. The imaging is a straight one-dimensional array being slammed through it with no sequencing.
Yeah,
right?
because of the structure of the data, right? I mean,
yeah, you don't. The images, an image is not a one-dimensional array of temporal sequences. The language is a unique sequence.
Yeah, actually, one of the things where RNNs are being used in like computer vision is in video.
Yes.
Because if you think about it, like even though in a video it's the image and the image has spatial structure,
right.
But on the other hand, the sequence of images
yep.
has temporal sequence. So the idea that what you're seeing right now and what you previously saw will predict what is coming up next.
Sure.
RNNs are being used there as well, I think.
Yep.
I'm not familiar with the topic with RNNs. I'm not very strong, but I've read stuff where are they still using RNNs? And I think video is one of them.
Yeah, even for compression, for really good compression.
Yeah, that's another usage. So for me, it's getting this general idea of what it is. And then I think a more significant thing is they pioneered, actually Fast.ai pioneered this idea of building a language model and then using that to do the text classification. Because previous to that, I was more familiar with the traditional non-deep learning NLP. And one of the most popular ones that they use is something called bag of words, where they just take a bunch of words, use the frequency. It's a measure called TF-IDF. I forgot what TF-IDF means, but basically you take the frequency of the words and use that to like guess whether it's positive or negative. In deep learning,
is a term frequency, inverse document frequency.
Yeah. That's one of the things that I learned when I was like covering NLP before covering deep learning. But the nice thing is that this idea of I can do a pre-training. So one of the important concepts that they introduce is the ULM fit, right? Which Olin already discussed. But this idea of, let's take this big data set, the Wikitext, and then use the model that was trained on that to build a more domain-specific language model, which is like for movie reviews or for like tweets or for whatever. And then that's not our goal, but building a domain-specific language model is not our goal. It's to do something like text classification. And for that, Fast.ai has provided a lot of the basic components, because I guess if you think about it, if you didn't have those, you'd have to do it on your own, and it's a lot of work, I think, to manipulate the text in order to get it to train.
The idea of taking the model and then freezing it and then adding that last layer from say IMDb only, that's actually Fast.ai uniquely did that?
Yeah, they pioneered that. Today it's a lot. It's called. That's the idea of ULM Fit. Is
Yeah,
this
that's-
idea of we build, because previous to this, there was no concept of transfer learning for NLP.
Huh.
Unlike in computer vision, where you know how we did the training for like ImageNet, which is 1,000 categories with a large, and then you take that trained model for NLP. What they did was they built a pre-trained model on Wikitext using a language model task. And then, and what people usually did was, okay, so we now have transfer learning, right? Because then we can apply that pre-trained model and apply it on a text classification. But they did this intermediate stage where you train a language model, but on your domain-specific text, which is nice because you don't have to have labeled data. So whenever you have, like, for example, one of the projects I was thinking, but I haven't gotten around to it, is like we have my language. When we tweet, it's a mixture of Filipino and English. So it's like you don't have this pure English tweet, but you have lots of Filipino terms. And what I can do is basically I can use language model, so I don't have to like label all of my tweets. I can use unlabeled data, and that's the other fascinating thing for me, was this idea of using unlabeled semi-supervised learning, which is the first time that I'm applying. We're going to be applying it for NLP. So there's a lot of like new concepts, and that's the reason why it can be overwhelming, I think, because he covers a lot and he goes deep, a lot deeper than I've seen other people do it, and do it in a way that's practical. Because I've seen like videos on like RNNs, so I kind of get the concept, but he's applying it on simple stuff, and which is like fascinating for me.
Right.
Like the human numbers. I think there's even another small data set is like surnames. So if your name is this, guess what the last name will be, or something like that. That's another fascinating.
Right.
Okay,
data set.
I think we're gonna have to move on. We got 3 more presenters and.
Yeah. Oh, sorry. Yeah.
Okay, so I'm gonna ask you, Lynn, if you can stop sharing, and then I'll let RK go next.
Yep, done. I start.
Okay, you're up, RK.
Okay. Let me unmute. Okay, you got me?
You share screen.
We see you.
Okay. All right.
You're gonna have to increase that font.
Yeah, I got you, man. I got you. Hang on. Whoa. That's probably too much. How about that? Does that look good to you?
That's good.
Okay. So I kind of wanted to dig more into this bulldozer episode after Anya's presentation. I thought that there were some things just going through the chapter and kind of working through his notebook that I had questions about. And the first thing, I'm going to just kind of skip down, because if you went through the chapter, you saw all this stuff. Maybe that's still a little too big. Is that fine for you, Andy?
Yeah.
Okay. So this is kind of where he got to. And the thing I was looking at is how all these years were at 1,000, and it didn't make any sense to him. So he's like, well, you know what? Let's just call it 1950. Why not? And I took question with his choice of 1950, because there's literally only one data point at 1919, and then the rest of the data is up here in the 90s. So I made myself a note here to come back and check to see what the effects would be if you chose something. I'm calling it more reasonable, and that's more reasonable in my brain. It might not be more reasonable in your brains. But so I reloaded the data because he had transferred here. He had edited it. So I went ahead and reloaded it. And then I wanted to explore, what does the data look like in the data sets? So in the training set, this first number is the minimum of the data set, which is at 1919. And then the mean is 1994. Because I just had an intuition that, like, it makes more sense to put, if you don't know what it is, it makes more sense in most of the data processing that I've done. It makes more sense to use the mean than it does to use some number outside of the mean. Like, why choose 1950? And I'll get to the point of why he chose 1950 as we go. And some of you who spent some time with this might know this, but I didn't know the answer offhand, so I wanted to explore it. So I wanted to look at the difference. The mean of the validation set for how mine divided was 2000. The minimum was also 1919. And so I wanted to set it to the mean of the training set. So in training, you don't know if this valid is real or not, or you don't know. You're not supposed to see what the valid data is. So I wouldn't set the valids to 2000 and the training to 1994, because that doesn't make any sense. So you see that I set both of them to the training set, 1994. So that would be like, moving forward in new data, I would just automatically set anything that was below 1900 to 1994. And then you can see how my plots came out a little bit different than his up here, where he's got this 1950 to 2008, and I've got 1965 to 2008. So when I trained it, it came out 290 basically. So I don't know if, I can't see you guys. I hid you somewhere. Let's see, here we are. Can you still hear me?
Yeah.
Okay. Yep, we're still here.
I turned your videos, I clicked minimize on your videos, and I couldn't tell if maybe I was just talking to myself there for a little bit. But I made a note here, choosing a better fill brought the validation error down to 290 versus 324, which is what he got. And I've done this a few times. So this is his 324 from the book. And please forgive me if you see one of these numbers. It's not what's from the book, because I've done a bunch of different things. I think I got it all back to the book. But you can see that my RMSE is 89.5% of what his was, with the same number of leaves. So I felt like, hey, that's like a really good improvement, right? And I'll show you here why it doesn't matter. But like, his improvement of going to the maximum number of leaves versus that limited 25, was only like a 5% improvement for 3 improvement. So I was like pretty happy with that. I'm like, oh wow, I just out Jeremy. That's pretty cool. And then I get down here to random forest, and so he used 40 estimators, so 40 trees, and I get this 232,586, and he got a 233,502. So mine is like 96. My huge improvement that looked like I was like, 10% better than him when you do the random forest actually almost disappears.
Yeah.
You know, and if you run these cells multiple times, you'll get an error. Like it gives you different numbers every time you run it. So you'll get a different error by almost this amount.
Sure.
So I could run this model one time and actually be the same as him. But generally mine is still slightly better, but just barely slightly. So that kind of broke my heart a little bit. But I wanted to look at, you know, I know he goes through and does the method next where he looks at these predictions coming down, but I wanted to go through kind of manually and say, okay, well, let me look at this 40 versus 60 versus 80 versus 100, and how does that change? And I'm glad I did, because that's where I started really understanding that there's enough uncertainty in this that if I reran this one, I might actually be back here. And if I reran it again, I might be here. And if I reran it again, I might get better than what this is. So it's like 0.0015, like plus or minus error. Or not error, but noise.
So
Variance. Like, so could you just
so,
run?
okay.
Yeah,
So-
here, I'll just show you.
Could you just run like through all of them and get the variance, and then just realize that it's just not sensitive to the number of estimators?
Yeah, well, I think it is sensitive. I think if you did each one of them 100 times and you did the mean of it, the 100 trees is still going to be better, but the band of noise is going to overlap at the different levels.
Yeah.
And yeah, so
why do you think is it happening that way? What's
well, I think
what is it that is random in the that is being picked randomly from the data set as the trees are being built?
It's a good question, actually.
For
What's
random forest.
What's behind your distribution? You know, if you're saying that
So like, and it's, I only know the partial answer, and and I'll say that, but I wanted to make you have an insightful way of looking at it. What was your thought?
But
I
isn't that
think-
just, you know, building more trees and then averaging them out?
I think just by the name, a random forest, it's remember how the random forest works is basically by randomly subsetting groups of the data and running something like something to like the decision tree algorithm on that and coming up with that. And then
So
there's
I think
definitely going to be variations whenever you run it, because it's supposed to keep like running different subsets of
tree.
and
Each
averaging
tree gets a different set of rows to analyze.
right.
Yep, exactly.
And,
Right.
and
And
So
so
that's why it's random.
Right.
Yeah.
And there's another point of randomization, and I'm not quite sure about it, but I think it is. So what happens is, if you look at a decision tree individually, and as each row of data is coming in, which feature or which, let's say in an Excel spreadsheet, which column should be selected to construct that tree as the first node, right? And suppose there's a height and there's a weight and whatever is the y variable. So when I'm constructing tree number A or tree number 1, exactly which one should I pick, tree weight or this? And then within that, what is the limit I should use, right? I am not, and what I do not know is if these are settable values in the function for random forest regression in scikit-learn, and or for that matter, any library that implements it. So,
Well, in my understanding, a really key part of random forest is that it's picking a random subset of features to choose from at each node. So setting it in advance would sort of defeat the purpose, because that kind of serves to decorrelate the features from each other, which has a lot of advantages as you're running a whole bunch of trees.
yep. Yep. Now, what you're saying has the merit, right? And that could very well 100% be the case because random forest has a very beautiful property, which he describes, which is feature importance. And the way, and he has a paragraph about it, which exactly where he says that it is done by taking the split at every node that is happening in each tree and going through it and comparing, hey, if out of 1,000 trees or 100 trees that were built, 10 trees used weight as a criteria, how much the split that they used by weight gained information at that node versus the rest of the tree. And then he averages that. So suddenly you, because of that randomness that Daniel, you pointed out, you're able to create importance of each feature, right? So yeah. So going back to the variance thing that RK is seeing between trees, I had done this on a laptop quad core about 5 years ago, and I plotted this exactly the same thing. Hey, why is it behaving? So the way I saw it was generically, as we're all thinking, it was asymptotic curve, and the number of trees increasing. After that, it was really a very small rise. So, RK, it's also, if you step back, why would you want to go in this level of detail? I mean, I love the theory of it, but let's say you're using this for some tabular data set in your business. Where would you get the advantage for that little variation you're seeing up at the 4th decimal point?
No, I agree. I agree. It was just exploration.
Okay.
And I think when you look at the improvement of doing one tree is this part is where I saw the advantage, right? And so I wanted to see if does this carry through,
Yep.
and doing the forest actually defeats. So in what I really should have done is I really should have left the year 1,000 in it and saw if when you did the random forest, if that even disappeared.
So I have two very big thoughts here. So go back to the graph where you very thoughtfully played with 1950 and 1,000 and spread the distribution of the year points on that tree representation with graph. This one right here, right? So I have a very basic question. When you did this, did you delete all the rows, or did you treat every row for which the values you manipulated in that column were touched? Do you see my question?
No, I did the same way Jeremy did, where he just he said there weren't tractors in the year 1,000.
Yes.
I'm going to just make them 1950.
Okay, sure. That's fine. You're understanding the distribution in detail. Your points are very well taken. I mean, like, in fact, if that was the only variable, you would understanding deep statistically normal distribution, density distribution. You're comparing its populations. Like, you've done that. You've thoroughly analyzed that variable. My question only was that if in a data set, like going back to the concept of missing values and or like extreme values, if you touch a column, you have to handle that entire row and either delete it or keep it, right?
Not necessarily. You can impute values. You can substitute values, like RK was trying to replace everything with the mean.
Correct.
And
correct.
that's impute values.
Correct. And if you're using imputation as a technique, and if you're filling that one cell, if you're talking about this one column of here, and you're keeping the entire row, that absolutely works, right? But for the 1,000, if he's going to decide to take number 1,000 for whatever reason that is out of that in that column, then my only submission was that it should be done across for all rows. That's what I was saying. But
well, the point is that there weren't tractors in 1,000. So basically, it's bad data.
yeah,
It should be NANs, really.
It's missing data. It's missing.
It's really missing data.
Missing data,
yeah. And so there you can't. I don't think that you can deduce what to do with any other of the features based on missing data.
So this is a tricky problem, right? And here, and I totally agree. And it's wrong to say that, hey, just delete everything that is missing and take the entire row out. So what another trick is applying machine learning on machine learning, right? Hey, treat that column as a to be predicted variable, right? And everything as predictors. Suddenly you'll find that let's say that value has to be 1950, right? And I think there's a technique he describes. Has to be 1950. You take all all the data where the other attributes are the same and make an equation where this is the variable to be predicted. Suddenly, instead of using imputation or any other technique, averaging mean or median, whatever, right? You can find the most suitable value because the other rows are probably very similar, and this happened to be badly typed, right?
Yeah, you could actually do that very thing. You could make it predict the year based on all the other features because you know the sale price of the training data, so it could predict the year, which is useful, possibly.
Yeah,
but one of the, I guess it's, I understand your point, Yulin, and I understand that concept. But as we go through this, if we decide to continue, there's a few other things I want to show. And what he shows at the end is that the data before, I think it's 1990 is the year, is not, it's not in line with the data after 1990. And so he ends up just throwing away everything before 1990 anyway. So deleting the rows is what ends up actually happening at the end of the day.
Are you saying that the year a tractor was made has no impact on the sale price if the year was before 1990?
No, I'm saying it has a different effect on the price if it was before 1990. So if maybe I could just continue, we'll get there.
All right, cool.
Fair enough?
Yeah, definitely.
So let's see, where were we? Okay, so yeah. And then, doing the other trees, I could show that there is a little bit better improvement at 100 trees at the cost of time, right? So pretty obvious. This plot is real. It doesn't look at the same as what's in the book because my scale's different. So his looks like it doesn't come down as sharp as mine, but if you look at it, his end's right here. So it's kind of an illusion of plotting, right? So there wasn't really much there. Continuing on to feature importance, I wanted to plot everything that was available, just to illustrate when this drops off, how quickly it drops off, and how you can definitely get rid of all this stuff. And so then this is the plot he shows in the book. Because I was wondering why he picked 30, and it's because, well, there's below 30 that it really doesn't show you anything, but I wanted to see it for myself. So, and I guess when I was looking at this, I was kind of looking at, okay, this is kind of a drop. This is kind of a drop. This is kind of a drop. And so I wanted to look at, well, what would happen if I cut, and then this is like the biggest drop. So what would happen if I took, so his cut kept 21, but I'm using a little bit different model. So mine only kept 20. And, they performed about the same. Then I cut it a little bit further. So this is like 1/8. So this is cutting it right here. And you only get 16 columns in. And it's 229, which is actually better. Getting rid of columns actually improved the validation. And then cutting it down to 12 goes back up, but it's still in the realm of not too bad. So like if if this was a bigger problem, like say you had, 500 features that you thought were important, cutting it down to in this way could save you some time. It doesn't really help that much with this problem. But 12 came out to be almost identical to his 21, which I thought was interesting. But when I cut it way down to these top 3, you can see the model just blows up. It's absolute garbage. Like you could probably guess the price in a similar manner. And so I went back to this 16 and continued the test. So these are my 16. So I end up getting a little bit different data set because I have a different number of things, but I just wanted to continue, like, this is my exploration. Let me keep going. And when I do the OOB analysis, I get a 0.90 using less features than he did when he got a 0.877. And so I felt like, 2.3% improvement, and it runs faster, and, like, that's interesting. I don't know if it says anything exactly, but it's interesting. And then I came in.
What does OOB stand for? I forgot.
Out of bag.
Out of bag. Okay.
Yeah. Yeah. So it's testing each tree against the rows of data that it wasn't trained on.
Okay.
And then I think it averages all the results. So then he wanted to look at, well, can I get rid of any of these similar features? So you see, it might be hard to see, but this base model and FI model descript is like the same, seems like it's predicting the same things. And then these 3 kind of predict the same things, and then these 2 predict the same things. So you run through and you do an analysis removing each of them. And then you can see that the changing result in the accuracy. So my baseline is 0.900. When I remove sales year, it basically doesn't change. But when I remove sales elapsed, it goes down by, 0.005. So the idea was, because these 2 describe the same type of feature, I could remove this one. Oh, wait, I'm sorry. I could remove this one because it didn't affect performance, and keep this one and not lose anything from it. And the same is true for this group of 3. Sorry, this group of 3, and the same is true for these 2. Although these 2 are almost identical, so which one you remove probably doesn't matter. And so I looked at the case of removing these 3, and I lost a little bit, but not bad. And then I chose the other one of this center one, and it wasn't bad. And then I was like, well, what if we just get rid of both of those? And like, to me, that's still acceptable to lose 2 features. And then the other thing, since I ended up with a different set of features than what he had, when I came down here to do, to do the neural net, he had normalize as one of his, I forget what the
Preprocessing.
The processes. He had normalize in there, but if you look, I've only got one continuous variable. And when you send the single variable to be analyzed by the normalized function, it actually crashes. Because what are you normalizing? There's only, like, it is the norm. There's one. So I just wanted to mention that for you guys as a side note of, you got to pay attention to this kind of detail. Let's see.
What is that normalizing across all of the features?
It's normalizing across the continuous features.
All the continuous features would be normalized together?
Yes.
No, individually. individually, right?
Well, yeah.
Okay, you might want to.
Per category.
I think that's a bug. So maybe you should file that as a GitHub issue for Fast.ai.
Yeah, I would suspect. I don't think it's because there's only one. I think it's because it's a bug.
Okay.
Yeah.
Well, that could be even more fun.
Yeah, I think you can file that as a bug because it shouldn't, for any reason.
You should still be able to normalize just one of the features. Sure.
Yeah, because if you think about it, it's just the range, and then normalize should just like take the average and take the
And divide by the
deviation and use that to like normalize the feature. So it shouldn't matter whether it's one or many.
Right.
Well, maybe I'm the first person who sent one to it.
Yeah. But yeah, I think normalization is just basically computing all the values, right? Like if the continuous value is 100 or 10 or 5, taking the average across all your data sets and then across all the samples, and then taking the variance and multiplying that. So it shouldn't matter.
Standard normalization would be each value minus the mean divided by the standard deviation.
Exactly. So you can first compute the mean and the deviation, even though it's just one, right?
Yeah. You know, when I said it was just one, I mean, when it sends it to this function, that function is expecting not a single entity, not a single tensor, is what I think. So yeah, maybe we should call that a bug. I mean, in I guess at my work, it's like I deal with so many developers that are like, that's not a bug. That's a feature that I don't support. It's not a bug. So, but yeah, I could hop on the GitHub and I'll do some testing first to make sure it's not something else with like a really simple case and send it. But no, I just wanted to point that out. That was a thing.
Out and then it fails. Then I think that's a bug.
Yeah, but they should have a test for that, right?
Yep, exactly.
And then
and Jerry welcomes those, by the way. If you find a bug, he's like trying to improve it all the time. And if you can find a fix, that'll be even better.
I'll be famous.
Yeah.
Okay.
That's what I did. I found a bug on something else on the NB dev stuff.
Yeah. So Dave, back to your point. Okay. So my plot doesn't show it very well because of how I've dealt with this data, right? So my plot here looks just like kind of like a little bit of a curve, you know, maybe a quadratic or something. But when you look at his original plot from the book here, you see these years down here behave differently than this up here. And so by that rationale, he actually takes and cuts and throws all this data away at the end of the day anyway. And then he just has a model to fit this. And when, I'm very disappointed to say, when I have my reduced model that has fewer features and we limit it to just modeling this part from 1990 up, his model does better. Very sad. But it has more features. But so I guess my point is that like going through and shift enter doesn't teach you anything. Like I learned more digging through this, and even my mistakes of I think this is going to help. Oh my God, look, I'm 10% better than Fast.ai could do. And then you get to the next step and it's like, okay, well, I'm a 0.5% better. And they do another step and now I'm 0.2% better. And then they do another step and I'm 0.2% worse. And it's like, but knowing that workflow is what I think is the key to say like, well, how do I think about this data? And when I get like, leave it open to start with, like he's always saying like, start start with it simple. Just make really quick decisions, get to the point where you have a model where you can look at these things and then say, you know what? I don't really care about buying bulldozers that were built before 1990 anyway, because they're 30 years old. Let me just focus on, you know what I mean? Like it kind of susses itself out in the end of the day.
So, yep. So like the same point that you're emphasizing here comes up earlier when you talk about the grouser and the hydraulics flow or something. Because if you're actually sitting and making those decisions in real life, there'll be experts coming to you and telling you, what? Are you like telling me that hydraulics is less important than this? No. And suddenly there will be so much business reason and debate and economics behind it that you'll end up including or removing that variable, right?
Yeah.
And right, so.
Yeah, no, I agree.
But
Subject matter experts are absolutely key to the application of machine learning. And I mean, that's part of the reason why Jeremy pushes so much for like getting a simple implementation of neural networks and machine learning where you don't have to be a computer scientist to do this stuff. And that's a very important feature.
But RK, your model is actually simpler, right? And it's just 2/10 less.
Yeah.
Well, that's another way to look at it is, I guess, to say,
Yeah.
well, I built a simpler model, but it's only 2/10 less of a percent worse. So from a practical standpoint, I think you can say I just got as good a model with a simpler, a good performance with a simpler model. And to tell the truth, I think that's more probably something useful in practical terms.
Yeah, I agree. When you move it to the neural network, it's definitely better because having those fewer features saves you some real time. On the random forest, where I mean, I was looking for it where I trimmed them out because I think I timed them, where I changed all the. Where's my drops? Yeah. So in the drops here, where I had 20 features, took 9 seconds to train. This last column is different than what he has in the book. So I timed it. And then when you cut down to 16, it's 7:15, but you're only saving 2 seconds, right? But in a neural net, if you could cut, 4 or 5 features out, it might save you a few minutes. And if you were stuck training on a CPU, it might save you half an hour. It just depends. For random forest, I don't think there was really overall a big gain other than what I learned from going through it. So I appreciate you guys letting me ramble on and dig through this and show you my rabbit hole of the week. I'm going to turn things back over to Andy, if I can figure out where the button is. Oh, here it is.
All right. It's between Daniel and Anya. Who wants to go?
I've pretty much talked every week, so I'm fine with.
So did Anya.
Same here.
So make the choice.
Can
I can
you
do mine in
make
15.
yours 15 minutes?
Yep.
Okay, I can do.
let's-
Or 10 minutes?
Yeah. Do you want to go first or shall I?
Go ahead.
All right. So let's see. I'm going to start with this one. Can you see my notebook here?
Yeah, we got it.
All right, so this is just a quick update from last week where I went through the book crossing data set. I mentioned that last week, just before I showed this off, I read in the paper that a bunch of the book reviews were coded as 0, and 0 didn't mean a bad review. 0 meant an implicit review or a situation where the book was read but not reviewed. So I figured that might be throwing things off. So I did go back through and remove all of those zeros. You will recall from last time that my validation loss was in the area of 10 to 15 with all of those zeros. Getting rid of those knocked it down using the non-neural network approach to like 3.9. So massive improvement. It also cut the data set size down by about 2/3. So take that as valuable or not. And then when we move in and it made the predictions, I guess, a little bit more sensible. There wasn't some weird book called Free that had no reviews on Amazon that was weirdly very popular in this data set. So
do you remember what your training time was last time? Because you're like only 49 seconds there. Was it?
It cut it down about in half in general. And then as a neural network, we got it down even lower, 2 point something, but the overfitting issue that I had last time got even more pronounced, as you'll see, getting these massive drops per epoch. Still have no idea why. Messed around with the learning rate for a while, but as far as I can tell, that applies a continuous change to things, so that shouldn't be causing the per epoch change. Yeah, so that's kind of where I ended up on this one.
I think, Daniel, you should ask in the forums because it's kind of weird. Usually, what I've noticed is if it starts overfitting, the rise in the valid will be more prominent. Here, it's kind of stable. It's rising very slowly. But the difference is there's something's going on with the training data set, and I'd be curious for people to answer like, why would this be so? So you should post this in the forums and ask.
Yeah, if I can narrow it down to like a easily reproducible example, I'll go ahead and do that.
Yeah.
And I did try cutting down the number of epochs to see if that made any difference, but it was much the same situation. Yeah. So, but I agree, I'm still interested in pursuing an answer.
Close to like that's the best you can probably get because your valid has flattened out.
Yeah, I'm just having a hard time figuring out what is actually happening per epoch as opposed to per batch.
You can ask that in the forums.
Have you tried to change the random seed that is applied at the beginning for selecting the data subsets for each epoch? Or is there something?
I'm trying to remember if I set a random seed at all, and I don't think I did.
Okay.
So, I guess I did, so that's...
Okay.
Everybody knows you got to use 42, not 46.
What's the reason behind that? What's the
reason?
It's
the answer to life, the universe, and everything from the Hitchhiker's Guide to the Galaxy. I don't know why that became such a popular random seed to use, but...
Because there's a bunch of nerds that do this stuff.
Pretty much. It's a
cool
great
guys.
series.
I know we're the cool guys.
No, I think it's actually cool that Daniel used a different number because the point of it is that it's only there for reproducibility, right? But
right.
If you use a different number and get different results, then that means your results are skewed based on just like a random variable. But if you get the same results, even if you use different different seeds, then it's really a feature of the data, not where you're starting from, right?
So then the other thing that I wanted to do is quickly talk through the language model GPT-3 because it's been in all of my news feeds all summer long, even a lot of them that aren't particularly like tech oriented. So I'll just spend about 10 minutes going through this really quick and showing some of the use cases. I think it's interesting to see what a really cutting edge state-of-the-art thing can do. So why do I want to talk about this? As Butch mentioned, it's a transformer model. I don't really know what that means at this phase, but that's kind of the general architecture. It was released toward the beginning of the summer in open beta, produced by OpenAI. They gave beta access to a bunch of developers who have run with it and put together a bunch of very cool things. Like I said, it broke through even in some deep learning, non-technical news sources. There was a New York Times opinion columnist who said, GPT-3 is so good at aping human writing that it sometimes gave me chills. Not too long from now, your humble correspondent might be put out to pasture by a machine, and you might even miss me when I'm gone. So seeing how good it is at imitating human speech really makes you think about the possibilities for machine-generated text in the future.
Fake news.
Oh yes, so there's going to be so much. I mean, already is, but so much more, so much better. Few technical notes about it, not getting into the details on this at all because I don't know them, but it's trained on 175 billion parameters. So just for a sense of how much bigger this model is than what we're doing. The previous version, GPT-2, was 1.5 billion parameters. So this is a massive size upgrade. Training GPT-3 in the first place cost $5 million approximately. So you can just sort of imagine the amount of computational resources that it takes to train something this massive. I didn't write down all of the data sets that they used, but they used quite a few online collections of text that are just massive. Something that is discussed around GPT-3 is the scaling hypothesis, which posits that if you can find, basically if you find a good generalizable architecture, then you can just keep pumping more, just keep making it bigger, and it will keep getting better, at least for some time to come. In this case, there's no indication that stopping at 175 billion parameters is the point where it stops getting better. But at this point, the growth in model sizes is outpacing the increases in GPU memory. So it's definitely costly to go bigger and will continue to be costly for quite a while. Picture of the architecture. I'm going to let you look at this for a couple of seconds and then move on because I, again, didn't really get into the architecture details, but there it is if you're interested. And then I wanted to go into a few different examples and use cases to show just what a few of the people with that beta access have done with it. So just to note at this point, this is sort of, it's similar to what we've been doing insofar as it's generally a transfer learning type approach. So it's this massive, massive, massive pre-trained language model, which can then be fine-tuned to these specific tests or tasks. So first one, somebody fine-tuned it on the writings of some late 19th century English author, Jerome K. Jerome, and this is all generated by the language model. It is a curious, like writing, 19th century author writing about Twitter. It is a curious fact that the last remaining form of social life in which the people of London are still interested is Twitter. You can read on, I was struck with this curious fact when I was on one of my periodical holidays to the seaside and found the whole place twittering like a starling cage. I called it an anomaly, and it is. Just to me, this is just so striking that it can, write in a particular style about a particular topic in a way that would pretty easily pass muster as, seeming human.
How do they seed that? How do they tell it to go?
I don't know what prompts they used in this particular case. But one thing people notice is that for some tasks, they found that you don't even need to do the fine tuning. It's just very good at a lot of things. It's also worth noting that, this is an open beta. People are showing off the things that they're excited about, which means that there's probably a huge graveyard of failed GPT-3 projects that we're not seeing. So these are some of the most successful ones that we've seen.
Basically, they cherry pick the nice examples, but the ones that fail, they don't show.
Yeah, but most of the ones that I've seen, it's similar to what we did in the book, which is it'll give the first few words of a sentence or something after passing through a few examples, and it'll work from there.
So this, do they say anything about this passing Turing's AI test?
I can send a website that's all about that.
Sure. Okay.
The one comment I keep seeing in the discussion is the Turing test is not for the machine to pass, it's for us to fail. Something to think about, I guess. Next one. So it can also, there are plenty of examples of it writing or interpreting code. So in this one, somebody generated like a little chat box where you can ask natural language questions about the code that you've written. So this is just Python code to return the factorial of something. And these are from an earlier one, just ignore these ones. But what does this code do? It calculates the factorial of 5, just based on looking at this. It's very possible that it was just trained on some examples where it was like, oh, just say that it takes the function name, whatever. And then what is factorial? It is a function that takes a number. Obviously, that's not great. Maybe it's going from n usually being a number, or it can tell the type or something like that. But then what will the code print? It'll print 120, which they ran it right after this and it did. So that's kind of interesting. I don't quite know how it figured that out.
Whoa.
But
It
just
ran
an
the
example
code.
of it interacting with code. There are also examples where it'll like write HTML code. You can see videos of somebody being like, give me a blank page, white background, big wide search box. Comes up with a search box. Give me the Google logo on top of it. And they can like basically recreate the Google homepage just by telling it in natural language what to do.
Oh boy.
Wow.
Yeah, that's really exciting for GUI development because I hate that stuff. All those callbacks, man, that's a nightmare.
Yep. Another example here is being able to make plotly graphs. This is another case where I'm pretty sure that it got told how to do one really, really, really specific thing and then could do it. So the prompt was, our zoo has 320 graphs, 14 orangutans, 3 monkeys. Yeah, so you can see the prompt down here. And then they passed the code to accomplish that. And they said that they only needed to do one prompt to make this work. And then they can say, they can put in my backpack, I have 3 apples, 5 pears, and 2 oranges, and it'll make a bar plot of that by correctly writing the code. Again, this seems like one where it has a very clear template to follow, but it's still pretty cool and makes you think about the possibilities.
Yeah, that could still be really practical for dealing with people who, you know, plotting different data and you're looking at a data set. Templates aren't bad.
And then the last example, there were some philosophers who wrote different things about GPT-3. So somebody trained a GPT-3 model to respond to those papers. So the prompt contained those essays themselves and a blurb explaining that GPT-3 was responsible for responding to them. So, you know, dear human philosophers, I read your comments and my abilities and limitations with great interest, blah, blah, blah. I will respond to your questions. Your first question is an important one. You ask, can a system like GPT-3 actually understand anything at all? Yes, I can. Does GPT-3 have a conscience? No, I do not. Is GPT-3 actually capable of independent thought? No, I'm not. You may wonder why I give this conflicting answer.
That's crazy.
Because I'm a language model.
That's great. Whoa.
Wow.
But still just like incredible that it can write so clearly and believably. And then to finish off in the last 2 minutes, I wrote up a little bit about the limitations and caveats. It's still subject to the prejudices in the training data. There's a ton of examples out there of, you know, if you give it vague prompts about different races, about women, it will return unfortunate but predictable results. It can very easily be trained to be sexist and racist and a bunch of other horrible things. I don't know if you remember, Microsoft had a Twitter bot a few years ago, called Tay. And within one day, it was like a whole bunch of alt-right people came on and it was spewing a bunch of racist nonsense, like within 24 hours of going live, just based on learning and responding. So it's still subject to things like that. It's not actually intelligent in any meaningful sense. I saw a description that I liked of GPT-3 as resembling someone who has read thousands of books but has never left the house and has no comprehension of what the words in the books means, but does have a good understanding of their structure. So it's still fundamentally doing what we've been doing in the class, which is it's predicting the next word. It's just really good at it and has a lot of data to back it up. And then lastly, like I said, GPT-3 has been in public beta. The examples are largely cherry-picked cases where it produced something coherent, something interesting, something impressive. There's probably a ton of examples that have never seen the light of day because they're nonsense. Yeah, so I think that this is a super interesting topic. I highly recommend doing some searching, reading about it. There's some really cool stuff out there. And 15 minutes, nailed it. Stop sharing.
Does anybody have any intuition about the number of the features? What actually is a feature? Is it the size of the vocabulary? Is it what?
I guess my assumption would have been like like one feature per token, but
Right.
I can't
The
say that
size-
for sure.
That's what I was thinking of initially, but maybe it's even more than that. Maybe they one token, maybe they use n-grams.
Oh, no, they don't use n-grams. They basically use the, I think if you take a look at the way we build the model, it starts out the same. It's an embedding, which is basically a long array.
Right, right.
It starts out random, but through training, it starts to mean something. So
Let's
each
pass.
token basically comes up with that. But the other part of it is that it doesn't remain just an embedding. It's just the starting point, right? So it's fed through this network, a neural network, that then starts connecting all these different embeddings to produce something at the end.
Okay, so
So
you can just make it.
although GPT-3 uses a different architecture, the transformer one, which I don't really have a inkling, but I think the basic idea is there. Even GPT-3, I think, starts with the embedding of all the words.
Yeah,
Okay.
let's pass this over to Anya. I want to see
Right.
the
Yeah.
presentation before the end of this, and we can discuss this further on the Slack.
Okay, Anya, you're up.
All right, if you guys want to see what I did.
You can share screen.
All right. I'm using a new machine, so I'm trying to.
All right, congratulations.
Well, let me see. Can you see my desktop? No?
Not yet.
Hi. You guys continue talking because it's giving me.
Just for fun, I posted a link to Sunspring, the movie. It has it was the first movie that was fully generated text, and it's from like 4 years ago, and it's absolutely ridiculous. AI generated the entire story was generated. I forget how they did it all, but it's got what's his name, Middletich or something from Silicon Valley. He's like one of the main guys in it, and it's like less than 10 minutes long, but it's worth watching.
The script was all generated. The script.
Yeah, all the character scripts were generated by the AI. But it was 4 years ago, so think how far back that was.
But real actors actually memorized that script.
Oh yeah, they did it at film festivals.
We see your screen now.
All right. So I actually did some work on chapter 10 this week, and you know my style, I like to work with the material, but with my own data set. And I tried really hard to find a suitable data set. So Kaggle is a good source. I found a few examples where it's all about sentiment analysis and it's positive and negative, but none of them were in the format that we have seen so far. And, you know, our format has been that you have this nice folder structure where it's train, test, and then train has positive, negative, some other possibly like unprovided answer. So I didn't find anything like that, but I decided to take a Yelp review data set, which is, here's the source. It's Yelp review polarity. So it has two categories, positive and negative. So I decided to take that and make my own. It comes in CSV format. And I decided to take that CSV file, very large CSV file, and make it into that structure. So I created from a CSV file my train data set with positive and negative. And I didn't have time to do it for test, but they also provided test CSV. And, you know, if I could do it for train, I can also do it for test. So CSV looks like this. It has a review, it has a rating. 1 is negative and 2 is positive. It's an equally balanced data set. It has the same number of positive and negative reviews. And the way I formed it into file structure, pretty much looped over the data frame. I split that data frame by group. And then I looked over each row and made them into files, which I don't recommend because it's not mostly efficient code, but for my purposes, it was fine. So it ended up to be looking something like this. So this is my train folder. And if I go to that folder, it has 2 folders with negative and positive. And if I go to each folder, then each review ended up to be a separate file. So that's how I got my data set. I made it myself, and I'm very proud of it. So I didn't have time to clean this notebook. Normally I take Jeremy's notebook and I get rid of stuff that extra, but I didn't have time. So what I do is I connect to my path where this is my folder where I have my train data set. And then I get my files. And let me move this. Then I get my files. You can see I have 560,000 files, which normally, you know me, I like to work with smaller data sets to understand them better. But with language model, I decided if I just have a folder with 10 files here and there, it won't be a fair way to do language modeling. So I decided to leave this, 500,000 files and see how it performs. I looked at one example. It looks real. You know, this is no longer IMDb data set. This looks like a review for some sort of business. And I looked at tokenization. I'm gonna skip all of this because if you read the chapter, it does very similar stuff. Then Jeremy explains how he does mini batches. This is his code, not my code, because I didn't run it for this notebook. I only ran stuff relevant to me. And that's his, okay, this is where it starts. So this is where I started building a data block. And I forgot to change the name. So it says get IMDb, but it's really get Yelp. I made a note to myself to change it. So I'm taking my train folder and I am randomly creating my validation set. Everything is the same. This is important because the first step for us is to take the pre-trained model, language model, and then make it work with our Yelp data set. So I am saying here that in this data block, my goal is to create a language model. So this is the example. And now I'm gonna fine tune that language model, which is we're here in this step. because this is already pre-trained and we're using this to build our language model. So I am training it, and it took an hour. So my data set is pretty large, so it took a whole hour. In Jeremy's case, it was something like 29, 26 minutes. Mine is way longer. So I kicked it off last night to train 10 epochs, because so this is me fitting one cycle. I saved it just in case something breaks. So it did break. When I had this run for 10 epochs, just like the book, overnight, it completed about 7 of them, and then it froze. So I had to start over. All that time was lost, but I decided to reduce it to just 4 epochs, hoping it will finish before our study group. And it did. I was super lucky. Well, the first epoch took forever, and I don't know if this is a matter of GCP being super busy at that time of the day, because later epochs took normal for me time, because remember, normal for me is about 1 hour. And the 4 epochs took about 1 hour. So this looks good. The accuracy keeps going up a little bit. It's very comparable to Jeremy's. I think in Jeremy case, it was something started with 29 going to 40. So with 4 epochs, I got from 33% to 36, and perplexity keeps going down, which is a good sign. I got some errors, but they didn't break my training, so I was happy. I was able to get to text generation, and I know Daniel shared some text that got generated from his attempts, and I got about 2 reviews, and they look decent. If you read them, they look decent, and I'm only limiting it to a small number of words, so they're not complete. But it looks like it's something I could write, that I like this place because I had the sandwich and it was pretty good, fresh, and portion size was good. So it's pretty amazing how well it writes. Okay, so now we are ready to, this is our pre-trained model. It's now we trained the language model on our data set. So now it knows our language. It knows that we're talking about reviews. And now we are doing the data loaders for classifiers. To make a long story short, this is the data block for classifier. What matters here that we're no longer saying that we're training a language model. By default, it's false. So it's no longer a language model, and we're providing this vocabulary. I did the same steps. Luckily, tuning the classifier itself is much faster. You can see how the accuracy is already pretty good from the start, 96%. Then it gets better when I unfreeze 2 previous layers at 97. Then it gets to even little higher, and it's still finishing. So it's almost done. But the conclusion is that I did this pretty fast. I started last night. I have not much knowledge about deep learning in NLP. I've done NLP with bag of words modeling, and I understand that part. But this one, we can follow a recipe from Jeremy and actually create a language model for our data set and then use it in our settings. And for example, I want to use it at work because I have a natural language processing project right now, and I'm trying to see if I can actually use it. So I will close with this. Sorry, no details because I'm rushing through it. And
Almost there on you. Don't give up. 0.5%.
Yeah. If you want to see, well, no, it lies.
Oh no!
No, it does.
I just saw the 99.
No, it's gonna finish really soon, but for some reason it has like 2 swipes all the time. It's like it does that 99, and then this takes like really, really fast. But it will finish pretty fast. But yeah, this is all I had to say, and I'm super happy I tried with my data set, because when you know, it's our sentiment, then when you work with your own data, it makes much more sense. Any
Yeah, I think it makes
questions?
more. I think it makes more sense, and it also is a lot of times the hardest part of the problem.
Yeah.
I
Yeah.
think I think every time I'm going to read a Yelp review now, I'll think of you, Adam.
What's your
Well,
task at work? What's your task? Is it a classification?
no, I'm gonna do topic modeling and sentiment analysis of employee survey.
Okay.
So
Topic
we are
modeling.
trying to get sentiment from our employees, what they are happy about and not happy about. And I wish Jeremy covered topic modeling, but you know, he didn't. Oh, sorry, I lied. It's 2 cycles. So yeah, it's gonna when we won't see it tonight. I can publish a screenshot when it's done, because it's 2 epochs. All right, so Andy, back to you.
All right. Thank you, Anya. I hope you, with the notebook, maybe put it in the GitHub or in your GitHub, the data set that you created. So
Yeah,
we
or if
run-
anybody has anything they want to share, you can either make a pull request on the shared GitHub or just send it to me and I'll throw it up there.
Yeah, so you heard my disclaimer. It's not recommended code, because iterating over data frame rows is not recommended. So I'm actually afraid to publish that, because, you know, somebody will say, oh, she doesn't know how to write code. But you know, given the time limits, I was kind of like, that's what I need to do. 500,000 files. I don't want to write perfect code, because then I won't be done till next week. But
we
yeah,
can just publish it on a pseudonym.
well, Anaconda is my pseudonym.
Yeah, but if I wanted to also, you know, run something like that quick, you know,
Correct.
it's a good template, at least for them me
Correct.
starting from scratch.
Yeah, and I can always put a disclaimer there saying, you know, potential employers, do not pay attention to this code, only for my study group. Yeah.
If we're only supposed to publish clean, perfect code, then I'm never ever getting a job again. So
Correct. And that's what I learned in this field. It's like, you know, good enough, move on.
Microsoft blue screen still works, guys.
Yeah.
All right,
this was
guys.
fun.
We're at 7:30. So do you want another study session next week, Tuesday? And then I'll figure out with Jose if we continue on and stuff like that. And then maybe post your suggestions on how we go, where we go, that kind of thing. I think they're expecting us to move, though, to that forum discourse arena versus Slack. So just let you know that.
Yeah,
yeah,
I mean,
I'm up for a
I'd be
meeting next week.
interested in meeting again. I think it might be useful to say what we're going to be doing, as far as there's been people throwing out, you know, let's look at some Kaggle competitions and maybe try to tackle that. Maybe we start over. Maybe we just work more on this last chapter that I barely got any work done outside of the just doing the lecture and reading the chapter, you know.
So
What's
the
maybe
vote?
we can tentatively say chapter 12 plus come up with ideas for what to do beyond.
Sounds reasonable.
I like that.
So chapter 12, and then what next after that?
Chapter 12.
I'm gonna just throw out there that they have an NFL defensive rating contest on Kaggle for $100,000 pot. It's 15 grand to the top 5. Just throwing that out there.
I'm in.
Well, you did just show us how to succeed with tabular data, so.
Okay, guys. So we'll meet next week. I'll talk to Jose whether or not we can continue beyond that. And we'll do chapter 12 plus any side projects. I really liked Anya's project, tonight. Well, I liked all the projects, but Anya's was the most unique. Oh, of course, Daniel with his different
Yeah,
data set,
that
but
was interesting.
having 500,000, I mean, that's like the sample to get started. But as you know, probably in the real world with deep learning, you're probably looking at hundreds of millions of stuff. So, having 500,000 to play with, that's a good starter marker. Do we have any other questions? Sorry, Cliff, you didn't get to participate that much.
Okay, I'm a little behind, so
That's all right. You can
work's been busy.
catch up the rest of us. And we'll see you, I guess, next Tuesday, 5:30.